In the stillness beyond Earth's atmosphere, where the inky black of the cosmos drapes itself across an ancient tapestry of light, a whispered concern has emerged. Did NASA detect a black hole moving toward Earth? Imagine standing at the threshold between warmth and void, watching a dark silhouette drift ever closer. A cosmic predator, silent yet powerful, drawing nearer on unseen currents of gravity. Could such a shadow truly be heading our way? If such an idea stirs your curiosity, feel free to leave a comment below. Tell us where in the world you're watching from, what time it is there, and if you find yourself drawn into these cosmic mysteries, consider liking this video, subscribing, and turning on notifications to continue exploring the universe's deepest questions together. In this opening chapter, the theme unfurls. The possibility, the science, and the fear wrapped in one simple question: did NASA actually detect a black hole headed toward us? The answer, as we will discover, lies not in sensational headlines but in the quiet rigor of observation, theory, and skepticism. First, we anchor ourselves in reality. NASA has not announced any black hole on a collision course with Earth, but the rumor began to ripple through online forums and speculative media. To examine it is to study how science and myth intertwine. Astronomers have, indeed, identified black holes within our galaxy. In 2023, the closest dormant stellar mass black hole to Earth was confirmed at just 600 light-years away, still incomprehensibly distant and posing no danger. NASA's Hubble and Chandra telescopes have recently detected a wandering supermassive black hole inside a galaxy 600 million light-years away, one that devoured a star in a tidal disruption event known as AT-2024 TV. Such discoveries are real and profound, yet none suggest an imminent threat to our planet. Black holes are extreme concentrations of matter, so dense that gravity traps even light within an event horizon boundary, beyond which escape is impossible. Supermassive black holes lurk at the cores of galaxies. Intermediate mass black holes hide in star clusters. Stellar mass black holes linger unseen unless feasting on companion stars. While we have confirmed black holes across the cosmos, none recent evidence points to one moving into our solar system. The hypothesis that one is approaching likely stems from misunderstanding of scientific findings or sensationalist misinterpretations. Sometimes, phrases like black hole on the loose or roaming black hole describe objects in other galaxies or far beyond our galaxy's core, not within dangerous proximity. For instance, Hubble recently detected a rogue supermassive black hole offset from its galaxy's center, but it lies hundreds of millions of light-years away, harmless in cosmic terms. Yet the question persists: could a black hole drift into our cosmic neighborhood? Some giant black holes are known to recoil or wander after galactic collisions, propelled by gravitational slingshots. Such hypothesized runaways might leave trails of stars or gas, but even these are exceedingly rare and distant. Still, the laws of physics do not forbid it. And so, in the borderlands between certainty and possibility, our imagination lingers. The real interest lies not in fear, but in pushing our understanding. Direct detection of isolated black holes in the Milky Way remains elusive. Astronomers rely on gravitational lensing or motion of companion stars. As recently as 2 months ago, the first isolated black hole in our galaxy was confirmed silent, invisible, drifting but not headed for Earth. Suppose we entertain a bold idea. What if a black hole were heading our way but remained quiet, undetectable until too late? Theoretically, gravitational wave observatories like the future LISA mission could reveal distortions in space-time from massive objects moving in our vicinity, but only if they are close and massive enough to produce measurable ripples. Today's X-ray and optical telescopes would pick up flares if a black hole began accreting matter, yet no such signal exists. So, what are we really seeing when we look at this rumor? Perhaps we are not looking at a real threat, but a metaphor and expression of our vulnerability, our yearning to peer beyond the veil. In the age of information, fear often finds shape in shadows, in the voids of knowledge where certainty dissolves into speculation. Could a black hole slip through our awareness, cloaked in silence? The answer is yes, but only if it were small, cold, and drifting without a companion. Unlikely, but not impossible. There is, after all, a haunting truth to cosmic motion. everything drifts. Our solar system spins within the galaxy, which itself moves relative to other galaxies. Across unimaginable timescales, stars are born, migrate, and die. It is not beyond reason to imagine a black hole passing within the outer reaches of our system, altering the orbits of distant objects in subtle ways. Some astronomers have speculated about an unseen Planet 9, perhaps even a primordial black holano larger than a baseball, but many times the mass of Earth. If it existed, it would be invisible except through its gravitational effects. But even this is still theoretical and echo, without a confirmed source. Some scientists began to wonder, what if the black hole myth reflects not physical danger, but philosophical insight? We are tiny passengers aboard a fragile world, floating in a dark sea with currents we can barely perceive. Our instruments extend our senses, but only so far. We may look at the stars, but the silence between them hides more than we dare to imagine. In recent decades, we have launched observatories into orbit, mapped gravitational waves, and stared into the hearts of galaxies. Yet, for all our advances, the universe remains 95% unknown. Its dark matter, its dark energy, its hidden masses still shrouded in mystery. Could some of these invisible weights be black holes? Might they drift through space like ghost ships, steering the motion of galaxies yet never seen? The theoretical physicist Kip Thorne once described black holes as the most perfect macroscopic objects in the universe. And perhaps it is their perfection that unnerves us. No light escapes. No structure survives. They are endings without form, gravitational graves that swallow the stories of stars. Perhaps, then, the rumor of a black hole moving toward Earth touches something ancient in the human spirit, a fear of unseen doom, a fascination with the ultimate edge. Yet it also inspires curiosity. It reminds us that we are still learning, still seeking, still vulnerable and wondrous in the face of the unknown. As geology, physics, and astronomy converge, they frame our place in the universe as both precarious and resilient. Perhaps what matters most is not whether a black hole is approaching, but how we see ourselves as explorers seeking truth, not succumbing to fear. At the close of this chapter, the question remains open, not in dread but in wonder. If we truly lived in a universe where black holes drift unseen toward us, what clues might we still be missing? From the ancient deserts of northern Chile to the icy quiet of Antarctica, we have built machines that stare into the stars, mirrors, and lenses, crafted to catch whispers of light from the farthest reaches of time. Yet, for all their power, even the greatest of our telescopes cannot see everything. Some truths are too dark, too silent, too hidden within the fabric of space itself. These are the realms of the black hole, the cosmic eraser, the invisible hand in the celestial dance. But what if the black hole is not simply a monster hiding in distant galaxies? What if its presence is much closer than we imagine, not in a headline or hoax, but in the invisible architecture of our own solar system? To imagine such a thing is to peer into the very heart of a modern mystery. Not long ago, astronomers began to notice something strange. Far beyond the orbit of Neptune, in the icy band known as the Kuiper Belt, small celestial bodies moved in unexpected ways. Their orbits were elongated, tilted, clustering together like leaves caught in a hidden current. This behavior, it seemed, could not be explained by the known planets alone. Something else was exerting its gravitia, massive presence, unseen but undeniable. The idea was simple yet profound. Perhaps a ninth planet, a massive and distant world, was lurking at the edge of our solar system. But as the data accumulated, another, more exotic possibility arose. What if, instead of a planet, this mysterious object was something far stranger? What if it was a primordial black, wholly ancient, silent, and no larger than a bowling ball, yet many times the mass of Earth? The concept, though speculative, is grounded in real physics. Primordial black holes are hypothetical remnants from the earliest moments after the Big Bang, formed not by collapsing stars, but by quantum fluctuations in the universe's first fraction of a second. Unlike their stellar cousins, they could be small, microscopic, even but incredibly dense. If one existed nearby, it would be almost impossible to detect. It would emit no light, reveal no surface, and betray its presence only through the gravitational pull it exerts on other objects. This is the mystery some astronomers now contemplate. Could such an object be responsible for the strange motions in the Kuiper belt? Could a primordial black hole be orbiting our sun right now, hidden among the shadows, influencing the solar system like an invisible god? In 2019, scientists suggested that a black hole with a mass 5 to 10 times that of Earth could fit the data, and if so, it might be no more than a few hundred astronomical units away, still within the realm of our star's distant dominion. But how would we find it? We cannot see it directly. Yet, as always in astronomy, shadows reveal what light cannot. Researchers have proposed searching for gravitational lensing events moments when a black hole might briefly bend the light of a distant star as it passes in front of it. Others suggest examining the cosmic microwave background for unusual patterns, or hunting for rare bursts of radiation caused by the interaction of dark matter with such a black hole's extreme gravity. To this day, the evidence remains inconclusive. Planet 9 has not been seen, and no black hole has been found. But the orbits remain peculiar, the data stubborn, the mystery alive. And so the idea lingers somewhere far out there. A dark mass may circle our sun, cold and forgotten, shaping the edges of our world with invisible hands. If such an object exists, it would not be a threat knot in the way the rumors suggest. It would not plunge toward us with destructive hunger. It would continue on its ancient path, orbiting the sun every 10 or 20,000 years, indifferent to our presence. Its influence would be quiet, gravitational, a gentle but persistent tug, felt only in the slow drift of ice and rock beyond Neptune. And yet, the implications are vast. To confirm such an object would be to discover a new member of our cosmic family, one older than any planet, a relic from the universe's birth. It would also challenge our understanding of matter, of formation, of what the early cosmos was capable of. It might even hint at the true nature of dark matter, that invisible substance that binds galaxies together yet remains unseen, unknown. In this way, a single idea black hole hiding in our solar system connects the distant past to the present, the smallest scales of quantum physics to the vast structures of galaxies. It is a bridge between what we observe and what we suspect, between the measurable and the mysterious. Such is the power of black holes not only as physical objects, but as philosophical beacons. They compel us to ask harder questions, to consider the unseen, to accept that our knowledge is not complete. They humble us with their silence, their elegance, their indifference, and in their darkness, we see the outline of our own limitations. Some ancient myths spoke of devourers, of invisible forces that could consume stars or gods. They may have lacked the mathematics, but they grasped the emotion, the awe, the fear, the draw of the infinite. Today, we have equations instead of stories, but the feelings are the same. We stand at the edge of what we know, looking outward, and wonder what shapes move behind the curtain. Perhaps we will find that there is no Planet 9, no black hole, only a flaw in our data or a misunderstanding of celestial mechanics. But even that would be a discovery, a sharpening of our vision, a lesson in humility. Or perhaps, one day, we will catch a flicker of lensing light, a ripple of gravity, a curve in the fabric of space-time that proves the impossible real. Until then, we continue to search not out of fear, but out of curiosity, not to flee the shadows, but to understand them. For in the great silence between stars, it is our questions that echo the loudest. And so the chapter closes not with certainty, but with hope. Hope that we may yet see the unseen, hear the silent, and find within the darkness not danger, but knowledge. Beneath the icy crust of Europa, Jupiter's distant moon, there is an ocean dark, deep, and possibly alive. Beneath the vast deserts of Earth, there are fossils of stars, remnants of particles that pass through us unnoticed, ancient messengers from beyond the edge of time. And beyond the visible light of the cosmos, in wavelengths our eyes cannot see, there are shadows bending, pulling, shifting the paths of galaxies. These are not ghosts, but giants. They are black holes, and though we cannot see them, we see the worlds they shape. For centuries, the universe was thought to be steady, unchanging, a celestial dome that circled the earth in divine perfection. But today, We know the universe is alive with motion and transformation. Galaxies collide, stars are born and die, space itself expands. And in the heart of this dynamic reality, black holes are not exceptions, they are engines of change. In 2015, something extraordinary happened. The Laser Interferometer Gravitational Wave Observatory LIGO detected, for the first time in human history, a ripple in the fabric of space-time. Two black holes, more than 1 billion light-years away, had spiraled into each other and merged. That ripple traveled across the cosmos, untouched by gas or dust, unchanged by time, until it reached Earth and gently moved a mirror in a laboratory by a fraction of the width of a proton. And from that whisper, we heard their story. This moment marked a revolution not only in astronomy but in human perception. It proved that the universe speaks in many languages, not only in light and heat, but in gravity itself. We had, for the first time, opened our ears to a deeper cosmic song. And what it revealed was astonishing. Black holes, it turns out, are everywhere. Not just supermassive ones at the centers of galaxies, but smaller ones, scattered like seeds in the galactic field. LIGO's detections began to multiply dozens of collisions, each one a record of cataclysm, each one older than our species. The sky, once silent, now thrummed with echoes of ancient deaths. But what do these collisions tell us? They tell us that black holes are not rare nor quiet. They are born from the collapse of massive stars. Yes, but sometimes, perhaps, from more exotic processes. Some theorists wonder if there are black holes formed not from stars at all, but from the early pressure of the young universe. Others question whether dark matter itself could clump into these invisible entities. Still others propose that what we call black holes might not be singularities at all, but gateways, bridges, or illusions born from incomplete theories. Stephen Hawking once speculated that black holes might not destroy information, as previously believed, but somehow preserve it. That inside the darkness, the past is not erased, but encoded. This idea gave rise to fierce debates and wild possibilities. Could black holes in some way be libraries? Could the universe hide its memories inside these gravitational vaults? And if so, what would that mean for us? It would mean that black holes are not only destructive but preservative, that they are not endpoints but transitions. That beyond the event horizon, there may be a logic, a physics, a structure we have not yet understood. In this view, the black hole becomes not a grave, but a question mark, a punctuation in the cosmic sentence that invites us to read further. This brings us to one of the most haunting ideas in theoretical physics, the possibility of black hole interiors, not as empty singularities, but as regions of curved spacetime, perhaps even gateways to other universes. The Einstein-Rosen bridge, better known as a wormhole, is a mathematical solution that suggests two black holes could be connected across vast distances or across realities. Such structures, if they exist, would defy our understanding of space and time. We have no evidence for wormholes, but we do have mathematics, and mathematics often arrives before the telescope. It told us of Neptune before it was seen. It whispered of gravitational waves before we could hear them. Could it be that wormholes, too, wait to be confirmed? Some physicists believe that if wormholes exist, they might be detectable by the way they bend light or by the peculiar motion of stars around them. Others propose that they might briefly open and close, leaving behind bursts of radiation or unexplained lensing events. These are the signs we now look for, combing through the sky with algorithms and hope. And still, the mystery deepens. For as we study black holes, we find that they are not just objects, but paradoxes. They force our best theories to the edge of coherence. General relativity, which describes gravity so well, predicts singularities places where the equations break. But quantum mechanics, which governs the small, refuses to allow such infinities. The two theories, so powerful on their own, clash at the edge of a black hole. There, our physics falters. To reconcile them, we need a new understanding, a quantum theory of gravity, a unification of the large and the small. String theory, loop quantum gravity, holographic principles, these are attempts to weave a new fabric of reality. And in many of them, black holes are the crucibles, the places where truth will either bend or break. In 2022, physicists made headlines with experiments on simulated black holes in laboratory settings. By using analogs fluids, light fields, or ultra-cold atoms, they recreated some of the conditions around event horizons. These tabletop experiments, though not actual black holes, revealed behaviors that mimicked Hawking radiation and gave insight into the structure of space-time. In the lab, as in the cosmos, black holes remain teachers demanding, mysterious, essential. What they teach us is not only about the universe, but about ourselves, about our desire to know, to understand, to push against the boundaries of the knowable. We send telescopes into space not merely to collect data, but to feel less alone. We build detectors not only to find black holes, but to find meaning in the silence. For in the emptiness of a black hole, we hear echoes of our own questions. Who are we? Where did we come from? What lies beyond the edge? Perhaps that is why the idea of a black hole approaching Earth, however unfounded, touches a nerve. Not because we fear destruction, but because we are drawn to the unknown. Because we sense, deep within us, that the story of the universe is still being written and that we are part of its ink. And so, the narrative continues not in explosions or endings, but in the slow, spiraling gravity of thought, in the turning of galaxies, in the folding of space, in the listening. We do not fear the black hole because it is dark. We fear it because it is a mirror, reflecting our limitations and our potential. And if, one day, we understand them fully, what else might we discover hiding in the darkness? Long before telescopes rose above the clouds, before equations etched the dance of matter and time, humans looked skyward with eyes full of stories. The night sky, vast and shimmering, was once a scroll of myths and warnings, a celestial archive of dreams and fears. In those constellations, ancient peoples saw gods, beasts, and the bones of the world. But perhaps, just perhaps, they saw more. Could it be that echoes of black holes, these invisible titans of gravity, were known long before science gave them names? Among the ruins of past civilizations, from Sumer to Mesoamerica, strange symbols recur. Spirals, concentric circles, obsidian mirrors, and cosmic void shapes and metaphors hinting at something devouring, consuming, or watching from beyond. The Aztecs revered Tezcatlipoca, the smoking mirror, a deity of night and chaos often depicted emerging from a void. In Hindu cosmology, the dance of Shiva involves the destruction and rebirth of worlds, a rhythm not unlike the life cycle of stars and the eventual collapse into black holes. Of course, these are interpretations, not confirmations. Myths are not science. Yet science itself began with observation of stars, of motion, of time, and myths were the earliest framework through which we tried to make sense of the unknown. So we may ask not whether the ancients understood black holes as we do, but whether they sensed the gravity of unseen forces, the presence of devouring silence in the heavens. There are places on Earth where such possibilities seem almost to breathe through stone. Göbekli Tepe, a site older than Stonehenge by several millennia, stands in quiet mystery. Its megaliths are carved with animals and abstract symbols, their purpose unclear, their builders unknown. Some researchers have suggested that the site may encode celestial alignments, perhaps even stories about cosmic cycles far beyond the human lifespan. Could it be, as some have speculated, that these ancient architects bore memories of astronomical event supernovae, comet strikes, or even gravitational anomalies? The idea stretches the imagination, but not without precedent. In 2017, a study proposed that Aboriginal Australian oral traditions may preserve memory of meteorite impacts over 40 years old, an astounding intersection of culture and cosmic history. If memory can stretch that far, what else might survive in myth? And this brings us to a deeper question. Are black holes entirely external, or do they also exist as symbols within us? Carl Jung once spoke of archetypes, deep patterns in the human psyche that shape our dreams and stories. The black hole, in this light, becomes not just an astrophysical object, but a mirror of the human condition, a place of mystery, annihilation, transformation, a point beyond which the self dissolves. In meditation traditions across the world, practitioners speak of emptiness not as nothingness, but as the space from which awareness arises. In the vacuum of the black hole, where even light surrenders, we see a metaphor for ego death, for transcendence, for the dissolution of boundaries. Could it be that the cosmos, in its vastness, reflects not only physical laws but inner truths? Some scientists now entertain the possibility that consciousness itself may be more fundamental than previously thought, that the universe is not merely matter in motion, but something more participatory. Quantum mechanics already challenges our assumptions, showing that observation changes reality, that particles exist in states of potential until witnessed. In this strange terrain, the boundary between mind and cosmos becomes less distinct. What if black holes, then, are not merely things but processes? What if they represent not only an end, but a doorway? Some theorists suggest that the interior of a black hole may not be static, but ever unfolding, that from within the singularity, a new universe could emerge. This is the foundation of the cosmological bounce hypothesis, that our universe itself may have been born from the heart of another black hole, collapsing and expanding in an eternal cycle of creation. In this view, every black hole is a potential seed, every singularity a womb. The death of one world gives rise to another, like phoenixes nested inside gravity. This idea, while speculative, harmonizes with ancient myth, the belief that destruction is not final, but fertile. The Mayan calendar, often misinterpreted, did not predict the end of the world, but the renewal of time. The Norse spoke of Ragnarok, not as finality, but as a necessary clearing before rebirth. Modern cosmology may not use such language, but the rhythms are familiar. We speak now of cosmic inflation, of heat death, of multiverses, and eternal recurrence. We imagine time folding, space stretching, reality blooming again and again from singular origins. The mathematics is complex, but the sentiment is ancient. If black holes are indeed doorways, what lies on the other side? We cannot yet say. But if we peer into them not only with instruments, but with imagination, we begin to see them not as threats, but as bridges. They connect the real and the theoretical, the past and the possible. They whisper that the universe is not finished, not closed, not fully known. In recent years, the Event Horizon Telescope gave us our first image of a black hole's silhouette shadow of Mate 7's central giant. It was not a photograph in the traditional sense, but a composite, a symphony of data gathered by instruments scattered across the globe. Still, it showed us something profound, a ring of fire around a darkness that once was only theory. The image rippled across humanity. For a moment, we all gazed into the same mystery. Across continents and cultures, the same thought echoed. So that is what it looks like. A concept had become visible. The void had shape. The metaphor had teeth. And yet, the questions only deepened. What happens inside the event horizon? Does time stop? Does causality fracture? Could something beneath escape? Hawking radiation suggests that, over eons, black holes slowly evaporate. If so, what happens to the information they consumed? Is it lost forever, or encoded in subtle quantum states? These are not trivial puzzles. They cut to the heart of physics, of reality itself. The black hole, in this way, is a teacher through paradox. It shows us the limits of our knowledge and asks us to go further. It reminds us that even the most precise science must be tempered with wonder, that behind every equation there is a mystery. That truth is not a destination, but a journey, a gravitational pull we follow not to arrive, but to understand. And so we return to Earth, to our fragile world, orbiting a quiet star, surrounded by the echo of cosmic events. We are small, but we are also capable of seeing great things, of imagining beyond our senses, of listening for whispers in the dark. Perhaps the ancient builders, the myth makers, the stargazers, all sense something true note in the details, but in the essence, that we are part of a vast, breathing cosmos. That creation and destruction are not opposites, but partners. That within the darkness, there is always a spark. And if we follow that spark, where might it lead? Above the plains of Namibia, the sky opens like an ancient book, clear and unbroken, pierced only by stars whose light began its journey long before the first city rose from stone. In such places, where human light retreats and the cosmos stands naked, one can feel the presence of something, vast something, both infinite and intimate. It is in these silent vaults of night that we begin to see the universe not as a backdrop, but as a structure, living and evolving, shaped by forces invisible to the eye but undeniable to the soul. And among these forces, none are more mysterious or more foundational than gravity. Gravity is the sculptor of the universe. It pulls stars into galaxies, folds time around mass, and keeps our feet tethered gently to the earth. It is the weakest of the fundamental forces, and yet the most commanding on cosmic scales. And black holes, those dark wells of infinite gravity, are its purest expression. But to truly understand the role of black holes, we must look not only at their births or collisions, but at the grand architecture they help build. For black holes are not only ends, they are also anchor points around which galaxies swirl, structures form, and time bends. At the center of our own Milky Way, 26 light-years from where you sit now, lies a supermassive black hole named Sagittarius A. It is 4 million times the mass of our Sun, yet it takes up less space than the orbit of Mercury. Around it, stars orbit at speeds that defy ordinary intuition, some completing circuits in mere years. These stars, like cosmic test particles, allow us to measure the black hole's gravity and thus confirm its presence. In 2022, the Event Horizon Telescope revealed the first image of Sagittarius A, shadowing achievement of patience, coordination, and deep intellectual daring. It was a blurred, luminous ring surrounding a dark center, the absence of light revealing the presence of the unseeable. It was not just a picture, it was a revelation. And this black hole, this quiet sentinel in our galactic heart, is not alone. Every large galaxy, it seems, harbors a similar presence. Some are millions, even billions of solar masses. Some emit jets of plasma that stretch across thousands of light years. Others are dormant, content to drift in silence. But all of them shape the galaxies around them, not just gravitationally, but energetically. They regulate star formation, heat interstellar gas, and help define the galactic environment. Without black holes, the galaxies themselves might look nothing like they do. In this way, black holes are not isolated monsters. They are central pillars in the temple of cosmic structure. They are sculptors of the large-scale universe. And yet, for all their power, they remain shrouded. We cannot look inside them. We cannot retrieve anything that crosses the event horizon. They are the final word in secrecy, a physical embodiment of the unknowable. This has led some physicists to speculate that the universe itself may have a horizon not of light, but of knowledge. That beyond certain limits, information may be fundamentally inaccessible. That there may be truths which cannot be extracted, only inferred, only guessed at from the warping of what surrounds them. But even that warping tells a story. Gravitational lensing, the bending of light by mass, allows us to see the universe in ways once thought impossible. It lets us map invisible matter, study the earliest galaxies, and detect black holes not by their light, but by their shadow. In recent years, astronomers have discovered isolated black holes wandering the galaxy, not by watching them emit, but by watching them bend. A star dims, just slightly, just briefly, as a compact object passes in front of it. The data is faint, but it is enough. A silent mass has revealed itself, not by noise, but by its impact on the light of another. This method opens a new door. We may not need to wait for black holes to scream in X-rays. We can find them by how they touch the paths of others. But this leads to a haunting possibility. How many have we missed? The Milky Way may be home to hundreds of millions of black holes. Most are quiet, most drift. They are the corpses of ancient stars, scattered like tombstones across the stellar sea. Some may pass within a few light years of us, undetected, unremarked, but present. Could one pass closer? The odds are low, but not zero. Every star, every object, follows a path defined by the collective gravity of the galaxy. And just as comets from the Oort cloud sometimes plunge inward, perturbed by stellar nudges, so too could a black hole follow a wandering arc. If it did, we would only know if it began to interact with dust, gas, or another star. But if it were small, cold, and solitary, it might pass by like a shadow, leaving only mathematical ripples in its wake. Some researchers have proposed monitoring the precise motions of stars for just this reason. The Gaia mission, launched by the European Space Agency, maps the positions and velocities of over 1 billion stars. With this data, we can build a gravitational map of the Milky Way and possibly spot anomalies, objects whose mass betrays their invisibility. This search, though rooted in science, has the flavor of an ancient quest. We are hunting for dragons in the dark not of fire and wing, but of curvature and collapse. And what if we find one? What then? If a black hole were on a trajectory toward our solar system, we would know long before it arrived. Its gravity would distort the orbits of distant objects. It might draw in asteroids, comets, or gas. We would see flares. We would hear the music of motion. But even in the worst case, a close pass, a disruption of the outer planets, the Earth itself, would not be swallowed. The odds of such a passage are so low they border on fiction. And yet, fiction has a way of inspiring the future. In 1979, the film The Black Hole imagined a spacecraft plunging into one of these cosmic pits. Today, we dream of sending probes to the edge of the event horizon, not to fall, but to learn. Could we one day observe quantum effects near a black hole directly? Could we decode Hawking radiation and learn what lies beyond? Perhaps, perhaps not. But the desire itself is telling. It tells us that we are no longer content to watch the sky from a distance. We want to touch it, to listen to its silences, to send machines, and perhaps someday ourselves, to the very limits of space-time. And so, the black hole becomes more than an object. It becomes a boundary, a frontier, a challenge. And in that challenge, we find a mirror. We are drawn to black holes not only because they are strange, but because they are pure. Pure gravity, pure mystery, pure test. In their simplicity lies a paradox. They are defined by what they hide. And yet, in hiding, they reveal the deepest truths of our universe. So we continue to search, not because we fear what we'll find, but because we hope that in the finding, we'll understand ourselves more deeply. What are we, if not the universe becoming aware of itself? In the deep mathematics of the cosmos, there is a rhythm subtle, persistent, almost melodic. Galaxies spin with a grace that belies their violent origins. Stars pulse in measured frequencies, and even the void itself hums with a faint, residual echo from creation's first breath. These are not just accidents of nature, they are signatures, patterns etched into space-time, whispering that something deeper, something profoundly ordered, lies beneath the seeming chaos of the universe. And where there is pattern, there is code. Some scientists have begun to wonder, is the universe not just made of particles and waves, but also of information? Is reality, at its most fundamental level, not material, but logical and unfolding of computations woven into the geometry of space and time? The idea may sound like science fiction, but it stems from serious physics. The holographic principle, a bold hypothesis proposed by Gerard Hooft and refined by Leonard Susskind, suggests that all the information contained in a volume of space can be described by data encoded on its boundary. In other words, what we perceive as three-dimensional reality may, in some sense, be a projection like a hologram of processes occurring at the edge of the universe. This idea gained surprising support from black hole physics. When Stephen Hawking and Jacob Bekenstein studied the entropy of black holes, they discovered something astonishing. The amount of information a black hole can contain, the measure of its internal complexities, not proportional to its volume, but to the area of its event horizon. A two-dimensional surface encoding a three-dimensional interior, a boundary holding the secret of what lies within. If this is true for black holes, might it be true for the cosmos as a whole? Could it be that the universe, like a grand black hole, holds its deepest truths not in the visible stars and galaxies, but in the invisible math that defines its edge? Some physicists think so. In string theory, and particularly in the ADS, CFT correspondence developed by Juan Maldacena, the idea becomes precise. A universe with gravity can be fully described by a theory without gravity on its boundary. The world within and the world around mirror each other. And if such mirroring exists, then perhaps reality itself is emergent in appearance, arising from deeper, coded layers. In this view, Black holes are not just astrophysical entities, they are testbeds for understanding reality. They are windows into the machinery behind the stage. They challenge our assumptions about space, time, causality, and what it means to exist. But this raises a tantalizing question. If the universe is information, then who or what is processing it? This is not necessarily a religious question, nor a mystical one. It is a scientific inquiry into the nature of observation, measurement, and agency. In quantum mechanics, the role of the observer is crucial. A particle exists in a superposition of states until it is measured. Reality, it seems, is not fixed, but participatory. Are we then participants in the universe's unfolding code? Some thinkers, like physicist John Archibald Wheeler, suggested that information is the bedrock of existence. It from bit. He wrote the idea that every physical quantity, every particle, every event arises from binary choices, yes or no, encoded in space-time itself. In this light, black holes are not just absorbers, but editors machines that alter and refine the universe's informational ledger. But this ledger is not without gaps. Dark matter, dark energy together, they comprise over 95% of the cosmos, yet remain unseen, unfelt, unknown. We infer their presence by their gravitational pull and their effects on the expansion of space. But what if these phenomena are not substances, but artifacts? What if they are signs of information we have not yet learned how to decode? Imagine, for a moment, that what we call dark is not absent but encrypted, that the universe is not silent in these regions, but simply speaking a dialect we haven't yet translated. Some theorists are exploring models where dark matter arises from hidden symmetries, extra dimensions, or even the computational structure of space-time itself. In such theories, black holes may act as nodes in a vast, interconnected network bridging not only regions of space, but domains of physics. They may be repositories of forgotten information or gatekeepers of deeper laws. This brings us to another bold idea, the black hole firewall paradox. In trying to resolve the contradictions between quantum mechanics and general relativity, physicists encountered a dilemma. If information cannot be destroyed, then something must happen at the event horizon to preserve it. But what? One proposal suggests that the event horizon might not be smooth, but violenta, seething boundary of quantum fire, where information is incinerated and reborn. This would defy the classical view of black holes as gentle one-way doors. It would turn them into crucibles dynamic, unpredictable, and transformative. If true, it suggests that every black hole is not a prison, but a lab. A forge where reality is rewritten. We may never stand near one. We may never peer beyond the veil. But our equations reach where our bodies cannot, and our minds stretch further still. And perhaps this is the greatest lesson of all, that the universe is not merely a place we inhabit, but a language we are learning to speak. Every black hole, then, becomes a wordance, complex, hard to pronounce. Every gravitational wave, a syllable. Every particle interaction, a letter in the vast cosmic alphabet. And we, the observers, the seekers, are not separate from this script. We are lines within it, sentences forming and reforming as we learn, as we question, as we listen. Some have even suggested that consciousness itself may be a form of cosmic decoding, that the mind, in its wonder and awareness, is the interface between the written and the real. That by asking questions, we shape the answers. That by looking outward, we illuminate within. The black hole becomes, in this way, a symbol of the threshold, the place where information meets mystery, where certainty dissolves into curiosity, where endings become beginnings. And if the universe is indeed a code beautiful, strange, recursive, then perhaps every shadow, every silence, every black hole is an invitation to read deeper. What might we find if we learn to listen not only with eyes and ears, but with awe? Beneath the crust of awareness, beyond the limits of instrumentation and theory, there lies a feeling, a quiet intuition that something vast surrounds us. Not just in the physical sense, as stars and galaxies do, but in the metaphysical, as presence, as structure, as the architecture of something more complete than we have yet imagined. This feeling is not irrational. It is the whisper of the unknown pressing against the edges of what we believe we understand. And few things press more insistently, more mysteriously, than black holes. In earlier chapters, we explored their gravity, their paradoxes, their mathematical perfection. But now we turn to something even more elusive, what might lie beyond them. Because if a black hole is a door, what is on the other side? For decades, physicists have proposed that the core of a black hole might not be a singularity at all, but a passage. This is the seed of the wormhole hypothesis, an idea born from Einstein's equations and cultivated by those willing to venture into the edge of what mathematics allows. A wormhole, technically, an Einstein-Rosen bridgeace, a tunnel through space-time, connecting two distant regions, or perhaps two different universes entirely. Such ideas are not new. Ancient myths are filled with portals, gateways, sacred passages through which the hero travels into the underworld or returns from the stars. Today, we dress them in equations, but the yearning is the same, to connect the known and the unknown, the here and the elsewhere. If wormholes exist and this is still uncertain, they would require strange conditions. Exotic matter, for instance, with negative energy density, would be needed to keep the throat of the wormhole open. Without it, the tunnel would collapse too quickly for anything to pass through. Such matter has not been observed, though quantum field theory suggests it might be possible in microscopic, fleeting quantities. In this way, wormholes remain theoretical, beautiful, haunting, unproven. But what if? What if the interior of a black hole leads not to oblivion, but to origin? What if each black hole is the seed of a new universe, budding from our own like a cosmic blossom? Some cosmologists entertain this notion that our universe, vast and expanding, might itself be the interior of a black hole formed in another parent universe. In this recursive vision, universes beget universes, not in linear time, but in cascading hierarchies of curvature and collapse. It is a hypothesis bold in scope and rich in implication, because if true, it suggests that black holes are not only places of death but of birth, that every star's final breath might echo as a big bang in another realm. That creation is not a singular event, but a rhythm, pulsing through the multiverse, one collapse at a time. This aligns curiously with the notion of the bounce in cosmological models, where instead of an absolute beginning, the universe arises from a previous contraction. Time itself, in such models, becomes circular or spiral, not a straight arrow, but a recurring song. And black holes become the transition, notes the turning points in the melody. What might it mean for consciousness if reality is layered in this way? Could awareness, too, exist on multiple levels? Might black holes connect not only regions of space, but states of mind, epochs of understanding? It may sound poetic, but there is a quiet tradition in physics that honors this approach. Einstein spoke of the cosmic religious feeling, the sense that the universe is not random, but intelligible, that its patterns resonate with the deepest part of our thinking. And as we study black holes, we are forced to think in dimensions we cannot visualize, in equations we cannot fully resolve. Some scientists now investigate the interface between quantum gravity and the human mind. They ask whether consciousness itself might be a product of space-time geometry if the shape of reality, on the smallest scale, gives rise to thought and experience. In such theories, black holes are not just physical entities, but distortions in the very medium from which awareness emerges. There is no proof of this, but the pattern is compelling. When we look at a black hole, we are looking at the edge of knowledge, the point where physics breaks, where certainty dissolves, where the known gives way to the possible. And it is often at such edges that the most meaningful discoveries are made. Consider the paradoxes, the information problem, the firewall, the holographic boundary. Each forces us to reconsider what space is, what time is, what identity is. We begin to see that the universe is not composed of things, but of relationships, interactions, flows, resonances. In this web of relation, black holes are the knots, the dense junctions where the strands converge. They are the tests, the riddles, the unsolved pages in the book of being. And if wormholes are real, if the knots can be untied, then perhaps the universe is more open than we thought. Perhaps distance is not always separation. Perhaps time is not always forward. Perhaps identity is not always singular. In this space of possibility, even the human journey takes on new meaning. We are not merely descendants of stardust, but part of an unfolding story whose scope exceeds the bounds of our galaxy, our epoch, our form. We dream of faster-than-light travel, of stepping through one place to arrive in another, not across miles, but through the folds of geometry. Wormholes, if stabilized, could make this dream real. They could link star systems, they could connect civilizations, they could show us that the universe is not a vast prison, but a vast invitation. And yet, caution speaks. No evidence of wormholes has yet been found. They remain elegant solutions in equations, not realities confirmed by instruments. But even their hypothetical existence pushes the boundary of our imagination, challenges us to think beyond linear space, and reminds us that reality is stranger and more beautiful than we are often prepared to accept. So we continue to ask not because we expect immediate answers, but because the asking itself brings us closer to truth. And in the silence that follows each question, we hear the echo of something ancient, something vast. The black hole, once feared as the end of all things, becomes a symbol of new beginnings, a gateway, a mirror, a passage. And as we look into its darkness, perhaps we begin to see not the absence of light, but the presence of a greater order. What might lie beyond, we do not know. But if we listen closely, with science, with spirit, and with stillness, we may begin to hear the invitation. To go deeper, to travel further, to remember that every darkness is the shadow of something yet to be understood. Time, for us, has always been a river flowing forward, steady, familiar. We mark its passage with calendars and clocks, with heartbeats and harvests. But what if time is not a river? What if it is a landscapey, a vast terrain in which our minds merely wander in one direction, not because time flows, but because we do? Black holes challenge this perception at its core. Near the event, horizon-the boundary of a black hole where escape becomes impossible, time behaves in strange and disobedient ways. To an outside observer, an object falling toward a black hole appears to slow down, frozen in descent, its image stretching and dimming until it vanishes. But from the falling object's perspective, time flows normally until it doesn't, until it ends. This distortion is not poetic, it is real. It is predicted by Einstein's general relativity and confirmed by our measurements. The closer one gets to a massive body, the slower time moves. This is not illusion, but fact. On Earth, clocks tick imperceptibly faster at the top of a mountain than they do at sea level. Near a black hole, this effect becomes profound. Time itself warps, bends, nearly breaks. But what does this mean for our understanding of reality? It means that time is not absolute, that there is no universal now, that every observer carries their own clock, their own slice of reality, shaped by speed and gravity. It means that past, present, and future are not fixed destinations, but perspectives, entangled and relative. In the presence of a black hole, we are forced to ask a question that has haunted philosophers for millennia. Is time a thing that passes, or a thing we pass through? Some theoretical physicists argue that time may be emergent, that it arises not from some external ticking metronome, but from deeper relationships between particles and fields. In this view, time is not fundamental, but derivative, a consequence of quantum entanglement, of statistical order, of the direction in which complexity unfolds. Entropy's measure of disorder gives time its arrow. As systems become more disordered, we say time moves forward. But in the deep equations of physics, there is no preferred direction. The laws are symmetric. They work just as well backward as forward. It is only our experience, rooted in memory and decay, that insists otherwise. And black holes, once again, are the crucible. Inside them, time and space swap roles. The singularity becomes not just a place in space, but a moment in time, a future that cannot be avoided. In falling toward a black hole, one is not just approaching a location, but a destiny. All paths lead there. It is not a point one can orbit, it is a moment one must reach. This reversal opens doors to profound speculation. If time is flexible near black holes, might it be traversable? Could wormholes, stabilized with exotic matter, allow not only travel across space, but across eras? Could information or even consciousness move from one century to another through the tunnels of warped time? Some solutions to Einstein's equations permit such journeys. Closed time-like curves, they are called paths that loop through space-time and return to their origin. But such paths risk paradox, the grandfather conundrum, the causality crisis. If you change the past, do you erase yourself? If you receive a message from the future, who wrote it? Physicist Kip Thorne explored these ideas in detail, even consulting on stories like Interstellar, where a black hole's time dilation becomes a plot point, not just a spectacle. In that story, as in theory, time near a black hole stretches so extremely that a single hour might equal years for those farther away. The science is real. The implications are staggering. It means that in the distant future, black holes could become time machines not for visiting the past, perhaps, but for preserving the present. A civilization orbiting close to a massive black hole could experience time at a fraction of the rate of the universe beyond. 1,000 years for them might pass as millions in the wider cosmos. They could outlast the stars themselves, drifting slowly through time while everything else fades. Could such civilizations exist? We do not know. But the idea invites a broader perspective. If black holes can shape time, then they may also shape memory, culture, history. They may be more than physical objects. They may be cosmic sanctuaries, places where time is slowed, where change is deferred, where existence is protected against the erosion of entropy. Perhaps advanced beings, long before our kind, discovered this truth. Perhaps they left traces not in stone, but in space-time, in gravitational echoes, in anomalies we have yet to understand. And perhaps, in some distant future, our descendants will do the same, circle the cold remnants of collapsed stars, storing their knowledge not in books, but in the folds of time. The last stars will fade, the galaxies will drift apart, the heat death will approach, but the black holes will remain, for a while dark, silent, enduring. And in their orbit, if we are wise, may remain the embers of thought, the last witnesses of light. This vision is speculative, but it is not fantasy. It is what the physics permits. It is what the equations allow. And so we stand here, in a moment that feels fleeting, on a world that spins beneath a sun that will one day die. And yet, we reach with thought and telescope, with theory and awe, toward the most permanent features of the cosmos. Black holes may one day be our tombs, or they may be our vessels. They may be memory. They may be future. And if time is a landscape, then perhaps we are not bound to its riverbanks. Perhaps, with enough understanding, we may walk its hills, explore its valleys, and discover that the story of time is not a straight line, but a spirala path that winds through mystery and meaning, through darkness and dawn. Between galaxies, there is a silence so profound that it seems to swallow thought itself. It is not the silence of emptiness, but of distance, vast stretches of space untroubled by matter, where light takes eons to cross, and where even the smallest whisper of motion is rare. In this silence, black holes drift, ancient and alone, invisible unless they chance upon something to consume, and yet they are not forgotten. Because even in their quiet, they leave trace ripples, distortions, trails in the starlight. These ripples are more than metaphors, they are real. In 2015, when LIGO detected gravitational waves for the first time, the universe was found to be not merely seen, but heard. Two black holes, far away, had spiraled into one another and merged, releasing more energy in a fraction of a second than all the stars in the visible universe. But that energy was not light or sound. It was gravity itself, space-time, stretched and compressed like the surface of a pond struck by an invisible stone. This was not merely a confirmation of theory. It was the opening of a new sense, a new way of knowing. And since then, the gravitational wave observatories, LIGO, Virgo, Cagrahav, detected dozens more. Collisions, mergers, and perhaps even hints of more exotic events. Each wave is a message, a ghost of an event so distant in time and space that it reaches us long after its authors have vanished. But these messages are incomplete. They speak of masses and spins, of distances and orientations, but not of origin. We know two black holes collided. We know how much they weighed, but we do not know where they were born or how. The wave is pure gravity, uncolored, untethered. It does not carry fingerprints. And yet, we try to read them. Because black holes may hold secrets not just about physics, but about history. Where do black holes come from? Some are born from stars' massive suns that lived fast and died violently. When their fuel runs out, their cores collapse, and if massive enough, no force can stop the implosion. A black hole is born, not with a bang, but with a silence, a retreat into invisibility. Others may be older still. Primordial black holes, if they exist, were born not from stars but from the pressure waves of the early universe itself. Formed fractions of a second after the Big Bang, they would have been seeded by quantum fluctuations in the chaotic plasma of the infant cosmos. Some might be the size of atoms, others the mass of mountains. And they could be everywhere, passing through the Earth unnoticed, hiding in galactic halos, dark matter in disguise. The search for these ancient remnants is ongoing. Microlensing surveys look for their shadows. Gravitational wave detectors seek their echoes. And theoretical models try to predict where and how they might survive. If found, they would change our understanding of cosmology. They would be fossils not of biology, but of gravity. Evidence that structure existed before stars, before light, before atoms. But perhaps the most mysterious are the rogue black holes, those that drift alone through interstellar space, not bound to any system, not feeding, not seen. They may have been ejected by galactic collisions or flung by gravitational interactions. They are silent travelers, unlit, undetectable, save for the rare chance when they bend the light of a background star, revealing themselves in a flicker. In 2022, such an event may have been observed: a lone black hole in the Milky Way, about 50 light-years away, discovered not by emission, but by the way it magnified and distorted a distant star's light, a cosmic sleight of hand. A shadow without a body. These discoveries hint at a population of black holes we have never seen. For every one we know, there may be hundreds, thousands, even millions we do not. The galaxy may be littered with them silent graves of stars, scattered like ash across the void. And if they are so many, what stories do they tell? Perhaps they trace the history of the Milky Way itself, each one a chapter in the saga of stellar evolution. Perhaps their distribution holds clues to how galaxies grow and age. Or perhaps, more provocatively, they are relics of something else, something older. Some fringe theories, though not widely accepted, suggest that black holes might form from the collapse of dark matter clumps, or from the decay of topological defects in spacetime itself. These ideas, though speculative, speak to a deeper truth, that we still do not fully understand gravity. We do not know if it behaves the same on all scales, or if new laws await in the extremes. And black holes are the extremes. The densest, most curved, most paradoxical objects in the universe. They test our theories to breaking. They show us the edge of reason, and in their simplicity defined only by mass, charge, and spin, they conceal unimaginable complexity. It is this duality that draws us in. Black holes are both puzzles and mirrors. They are the most elegant solutions in general relativity and the most violent events in the sky. They are singularities, points of infinite density, and yet they are part of ordinary galaxies. They are destroyers and possibly creators. And in their study, we find not only the boundaries of physics, but the reflections of our own desire to know. Why do we care so much about what lies within them? Because in every black hole, we glimpse a kind of finality, a place beyond which our tools cannot reach, a mystery that resists explanation. And in that resistance, we see ourselves not as omniscient beings, but as seekers, always drawn to the horizon. Gravitational waves will continue to arrive, each one a ripple from some distant cataclysm, each one a chance to learn. And someday, perhaps, we will detect something stranger, a wave from an object that does not fit our models, a collision that suggests not two black holes, but a black hole and something else, a wormhole, a naked singularity, an object that doesn't collapse but rebounds. In that moment, theory and observation will collide, and what will emerge may be a new chapter in the story of the universe. For now, we listen. We build detectors more sensitive, more quiet. We tune our algorithms to hear what the cosmos is saying. And in the silence between waves, we wonder, what else is out there, drifting unseen? What ancient collisions have not yet reached us? What secrets still ride the curves of space-time, waiting for the right ear, the right moment, the right mind? There is a concept, almost too subtle to grasp, that the universe might remember. Not in the way humans remember with stories and photographs, but in the way that structure endures, in the way patterns repeat, and in the way every atom carries the imprint of a past explosion, every orbit the trace of ancient gravity. If the cosmos is a kind of mind, then black holes may be its memory-dense, unreadable, but absolute. This idea is not romantic fantasy. It is born from one of the most urgent paradoxes in theoretical physics, the black hole information paradox. At its heart is a question that sounds deceptively simple: what happens to information when something falls into a black hole? In everyday physics, information is never truly destroyed. Burn a book, and you do not lose the data. It transforms into ash, smoke, heat, and light. In principle, the book's contents could be reconstructed, given perfect knowledge of every particle and motion. But a black hole challenges this. When matter crosses the event horizon, it seems to vanish completely. No light, no particles, no escape. If that information is lost forever, then one of the core tenets of quantum mechanics is broken. But if it is not lost, then where does it go? Stephen Hawking first proposed that black holes might slowly evaporate via quantum effects near the event horizon, releasing what we now call Hawking radiation. This radiation is nearly random, carrying almost no imprint of what the black hole consumed. If the black hole fully evaporates, leaving only this radiation, then it seems the information has vanished. And so began a great debate. Some theorists argued that information must escape somehow, subtly encoded in the radiation. Others suggested it might be preserved at the event horizon itself, in a kind of cosmic skeena firewall of data. Still others proposed that black holes are not truly permanent, but decay in ways we cannot yet detect, returning the information slowly, like a whisper on the wind. More recently, a concept has gained traction: the soft hair hypothesis. It proposes that black holes do have distinguishing features, tiny quantum fluctuations at the horizon that store information about what fell in. These features, undetectable by classical means, would allow black holes to carry the past, not destroy it. If true, they would confirm that even the most silent places in the universe still remember. But this remembrance is not accessible. It is not like reading a book or hearing a story. It is buried in the math, in the language of tensors and symmetries. The information is there, but not for USA, at least not yet. And so black holes become not only mysteries of gravity, but metaphors for loss, for memory that cannot be retrieved, for stories untold. They are the locked vaults of the universe, holding the records of every star, every photon, every collision that crossed their thresholds. It is tempting to think of them as tragic, but perhaps they are simply patient. Perhaps the universe has always known that some truths take time to reveal, and this invites us to consider, what kind of memory does humanity leave behind? We launch spacecraft into the void Voyager, with its golden record, new horizons, now sailing past Pluto's shadow. We build radio beacons that call into the dark. We send data, pulses, math encoded as light. In all of this, we are trying to be remembered. Because memory is the antidote to extinction. To be forgotten is the final end. And in that light, black holes become terrifying not because they destroy but because they hide. They erase the record from view. They keep secrets. They do not forget, but neither do they share. Unless, perhaps, we learn how to ask. Some dream of future civilizations able to manipulate black holes to extract energy from their spin to mine their horizons for quantum data. In theory, it is possible. The Penrose process and Hawking's equations suggest that enormous power lies in the rotation of a black hole potential engine greater than 1 billion suns. A Type 2 or Type 3 civilization, in the Kardashev scale, might build habitats around such an object, harvesting energy, storing consciousness, preserving culture beyond the age of stars. This is not science fiction in the ordinary sense. It is science extrapolated to its farthest edge. a meditation not on what we will do tomorrow, but on what might be done in a billion years by those who inherit the sky. In that imagined future, black holes become sanctuaries not for bodies, but for minds, for memories, for the continuity of thought. And even if such dreams are never realized, they shape our present. They remind us that we are more than consumers of light, we are keepers of stories. That the universe may remember everything, but it still needs voices to tell its tales. So we look again to the stars, to the dark bands between them, to the quiet corridors where black holes drift, unwatched, unmeasured, but not unknowable. We ask, again and again, the oldest question: what is lost when something falls away? And in asking, we answer. Because the act of wondering is itself a memory of the stars that made us, of the earth that holds us, of the time we are given. The black hole, then, is not only the end of a journey, it is the beginning of reflection. A place where science becomes poetry, where knowledge becomes humility, where silence becomes meaning. And in that meaning, perhaps we glimpse the deepest truth of all, that nothing, not even light, is ever truly lost. It only waits to be understood. In the heart of every star, there is a struggling quiet war between gravity and pressure, between collapse and expansion. It is a balance so delicate that the slightest change can shift a sun from stability to catastrophe. And when that balance breaks, when gravity wins, a star dies not with a whimper, but with light so bright it can outshine entire galaxies. Yet in that final blaze, something darker is born. A black hole is not merely the end of a star. It is the beginning of a new kind of objective place where space folds inward, where time slows, and where the ordinary rules of matter dissolve into uncertainty. And as we ponder the birth and death of stars, another thought begins to form, one that quietly haunts the edges of our inquiry. Could black holes play a role not only in the fate of matter, but in the possibility of life? At first glance, the idea seems absurd. Black holes are hostile regions of intense gravity, deadly radiation, noxious accretion disks, and extreme time dilation. They are deserts, not cradles. But life, as we are learning, is often more adaptable than we once believed. It thrives in volcanic vents at the ocean floor, in Antarctic ice, in radioactive ruins. It clings to comets and clouds. It hides in places where light never shines. And so, the question persists not, could we live in a black hole? But, could we live near one? Could we draw from its energy? Could we survive in its shadow? In 1972, physicist Freeman Dyson speculated about black hole biospheres, theoretical habitats orbiting small black holes, powered not by sunlight, but by Hawking radiation. Though Hawking radiation is negligible for stellar black holes, it increases as the mass decreases. A black hole, the mass of a mountain, could emit enough radiation to warm a planet-sized structure placed at just the right distance. Such structures would require technology beyond our current imagination, but in theory, they could sustain life indefinitely far longer than stars, which burn out and die. A civilization that learns to tame or utilize black holes could outlast galaxies. And the allure doesn't stop there. In some theories, rotating black holes known as Kerr black holes might offer paths through space-time. If a spacecraft could approach the event horizon with enough precision, it might avoid destruction and emerge elsewhere, or elsewhen. While most physicists agree that tidal forces and instability would destroy any such attempt, the equations permit the possibility. And in the quiet corridors of theoretical physics, possibilities matter. They allow us to think beyond our constraints, to ask not only how we survive, but how we might evolve. What if a species could adapt not to light and atmosphere, but to the radiation fields near a black hole? What if intelligence itself could become distributed an echo of thought, sustained in magnetic fields or gravitational eddies? These are not answers. They are questions sculpted by curiosity. And that curiosity has brought us far. Already, we've discovered planets orbiting pulsars, dead stars that emit beams of radiation like cosmic lighthouses. These worlds are bathed in deadly rays, yet some may have atmospheres. Some may have subsurface oceans. We once thought no planet could survive such fury, yet they do. Might the same be true near black holes? Could moons or planets orbiting a dormant black hole, shielded by thick ice or magnetic fields, harbor the chemistry of life? Could black holes act as cosmic hubs not for life itself, perhaps, but for the environments that permit it? Some have even suggested that the centers of galaxies, where supermassive black holes reside, may once have been crucibles for the emergence of complexity. The intense radiation, the dynamic gravity, the richness of molecular cloud sol, these could create regions where chemistry flourishes, where energy gradients drive self-organization. It's speculative, but it's no longer unthinkable. And as we search for life in the universe on Mars, on Europa, in the clouds of Venus, we must also expand the scope of our vision. Life may not look like us. It may not breathe or move or think as we do. It may be slow or vast or scattered across systems. It may be flickers in plasma fields. It may be silent, hidden, old. And if such life exists, it may have found ways to use black holes not only for energy, but for time. A civilization orbiting close to a massive black hole could experience time at a different rate than the wider galaxy. While millions of years pass elsewhere, they might live through only thousands. They could outwait cosmic events, shelter through stellar epochs, and emerge in a quieter universe patient, enduring. Or they might already be watching. In recent years, some scientists have proposed scanning black holes for signs of artificial structures, Dyson spheres, engineered disks, or energy modulations that suggest intelligence. Thus far, nothing has been found, but the search has only begun. And the silence, too, is a clue, because perhaps the greatest lesson of black holes is not in their power, but in their patience. They do not shout, they do not reveal, they wait. And maybe, in that waiting, there is something we can learn, to build with care, to listen with humility, to understand that the universe is not required to be understandable, and yet it often is. The black hole, then, becomes not a threat but a teacher. It shows us the cost of collapse, the edge of endurance, the depth of mystery. It reminds us that survival is not the same as permanence, that silence can be full, that darkness can reveal, and that life fragile, improbable, radiant may find ways to endure even near the heart of oblivion. In that hope, we continue to search, not just for planets, not just for signals, but for meaning. In the still hours of the night, when the sky is clear and thought grows long, one can feel the immensity of what we do not know. Not just the distances between stars, or the darkness between galaxies, but the quiet weight of questions that have followed us since the beginning. Where do we go when we vanish? What happens beyond the veil? Is there a place anywhere where everything that was once lost is gathered again? Black holes do not answer these questions, but they embody them. To stare into a black hole is to confront an absence so complete, so perfect in its silence, that it feels like an answer in itself. A gravitational well that pulls not only matter, but meaning into its depths. A place beyond return. A cosmic punctuation where the sentence of being Ensor perhaps transforms. And yet, even here, there is motion. Even here, the story continues. Around black holes, material spirals. Stars are shredded. Light is stretched into rings of fire. Particles accelerate to near-light speeds, crashing into one another, birthing jets that burst across the void. These jets' narrow beams of radiation can reach across hundreds of thousands of light-years, affecting the growth of entire galaxies. From the center of silence, then, comes influence. From the unseen comes power. This paradox, the hidden shaping the visible, runs throughout the cosmos. Black holes are not just points of collapse. They are the beating hearts of galaxies. Without them, the structures we observe would not exist. They regulate star formation, heat surrounding gas, stabilize rotation. They are like the dark root of a tree, buried, invisible, but essential to the form above. And perhaps that is the role they play in our understanding as well. Beneath every theory, every calculation, every bright revelation, there is a core of unknowing, a place we cannot reach, a singularity not just of matter, but of understanding. And it is from that singularity that insight grows. Black holes, then, are not just astronomical entities. They are symbols of mystery, of transformation, of limits. They represent the places we cannot yet go, the questions we cannot yet answer. They are, in a sense, sacred. Ancient cultures often imagined sacred voidscapes between worlds, cosmic abysses, divine mouths that swallowed and rebirthed. In the Vedas, there is the concept of pralyath dissolution of the universe, followed by its rebirth. In Norse myth, there is Ginnungagap, the yawning void from which all emerged. In these stories, as in our physics, destruction and creation are not opposites. They are phases of the same cycle. And so, black holes return us to the oldest ideas of endings that are also beginnings, of silence that is also sound, of death that carries the seed of life. Even the language of physics reflects this. We speak of horizons instead of edges, of evaporation instead of annihilation, of information instead of matter. We speak, perhaps unknowingly, in metaphors because the reality is too vast for plain speech, because the closer we get to truth, the more it slips into poetry. But poetry is not weakness, it is recognition, that some truths must be felt to be understood. That wonder is not the absence of knowledge, but its foundation. And in that spirit, we continue to explore. We aim telescopes at the centers of galaxies, watching stars orbit invisible cores. We analyze gravitational waves, tracing the dance of collapsed giants. We model evaporation, entropy, entanglement. We dream of missions to the event horizon, not to land, but to listen. And always, we wonder, what lies beyond? Perhaps nothing. Perhaps something we cannot yet name. Perhaps, just perhaps, black holes are the boundary between the physical and the metaphysical, between what is and what it means. The physicist John Wheeler once said, "Black holes have no hair," meaning they are simple objects, characterized only by mass, charge, and spin. But in that simplicity lies an invitation to see beyond the details, to seek the essence. What is a black hole, really? A place? A process? A riddle? Or is it a mirror reflecting back our own desire to know, to reach, to make sense of the darkness? Perhaps it is all these things. Perhaps it is none. But it is here, in the equations, in the sky, in the story of every galaxy. And so we follow it, not to tame it, not to explain it away, but to walk its edge, to feel, for a moment, what it means to be small in the face of something great. To remember that we are part of a universe that contains not only stars, but silence. Not only answers, but questions. Not only beginnings, but the beautiful gravity of endings. Somewhere in the distant night, beyond the scattered drift of stars, a black hole rotates. It does not move with urgency. It does not shine. It simply exists, mass bent so tightly into itself that even light forgets how to leave. And yet, despite its silence, it speaks. Not in words, but in presence. Not to the ear, but to the imagination. For centuries, we looked to the sky and wondered who else might be watching. We sent messages, mathematical codes, pulses of hydrogen frequencies, etchings on golden records. We mapped the heavens as if preparing for a visitor, charting the routes between stars like ancient mariners plotting the oceans. And in this pursuit, black holes seemed like obstacles, voids between possibilities. But what if they are not only thresholds? What if they are beacons? Some scientists have proposed a startling idea that if there were other intelligent civilizations in the universe, they might not just avoid black holes, but seek them, not for refuge, but for purpose, for stability, for storage, for survival. Imagine a civilization so advanced that it no longer fears gravity, but uses it, that encodes knowledge not in books, but in particle spins near an event horizon. That harnesses Hawking radiation to power computation, using time dilation to extend processing across millennia. To such beings, black holes might be libraries, engines, even gathering places of deep time, where thought can endure as the stars themselves fade. We call this the realm of the Kardashev scale, a classification of civilizations by their energy use. Type I harvests the energy of a planet. Type 2 captures the output of a star. Type 3 masters a galaxy. If such beings exist, and if they value permanence, then black holes may be their monuments. We do not yet see such structures, but we are only beginning to look. The galaxy is vast. The signals we seek may be subtle. A modulation in radiation, a strangely stable orbit, a ring of matter shaped by intention, not chance. We search for the fingerprints of reason within the fingerprints of gravity. And even if we find nothing, the search transforms us. It stretches our sense of time. It expands our idea of intelligence. It invites us to see black holes not as endings, but as contextual markers in a continuum of purpose. For what is intelligence, if not the ability to reflect? And what is reflection, if not the bending of thought inward just as light bends inward near a black hole? Perhaps in that metaphor, there is something to hold. Perhaps black holes, so feared for their erasure, are actually mirrors not of our faces, but of our futures. They show us what endures, what concentrates, what gravity itself chooses to keep. And so, we begin to ask different questions. Not, how do we escape the black hole? But how do we endure near it? Not, how do we conquer the cosmos? But how do we harmonize with it? This is more than science. It is philosophy rendered in physics. And in this dialogue, something ancient stirs. Throughout history, humans have created temples, places set apart, designed not for answers, but for reverence. In many ways, black holes are like that. They are cosmic sanctuary zones, where the ordinary rules fall silent and the unknown breathes. In some spiritual traditions, the void is sacred not because it is empty, but because it is full of potential. In Taoism, it is the wuji, the undivided. In Buddhism, it is sunyata, the openness from which all things arise. And in modern cosmology, the singularity is that place not just where matter collapses, but where concepts dissolve. Mass, time, distance, identity. Inside a black hole, these may not mean what they mean here. And that is not cause for despair. It is cause for awe. To encounter the unknown is not a failure of understanding. It is the foundation of wonder. And wonder, unlike data, does not diminish with use. It deepens, it matures. It teaches us to be humble and curious and open. So as we stand on this small planet, circling a modest star in a galaxy among billions, we look to the black holes not with fear but with reverence. They are not intruders in our story. They are part of its shape. They are punctuation in the cosmic sentence commas, colons, and full stops. And perhaps like all good punctuation, they give rhythm, they give pause, they give meaning. We do not yet know if anyone else is listening. But in sending our questions out into the black, in turning our minds toward the mystery, we become part of something larger. A conversation written in gravity, a prayer whispered through time, a story not yet finished. At the edge of all things, where light folds and time narrows to a breath, there is a silence. It is not the absence of sound, but the presence of something deeper, quiet that listens, a stillness that endures. It is here, near the event horizons of black holes, that we find the most honest expression of the unknown. And it is here, too, that we must ask the most human of questions. What, if anything, lies beyond? Not just beyond the event horizon, but beyond this moment, beyond our species, beyond our epoch, beyond the long arc of stars and stone and civilization. What legacy does a civilization leave when even its atoms are scattered? Black holes, in their strange way, force us to think long, longer than empires, longer than oceans, longer than the age of the sun. They remind us that everything we know is temporary, but they also remind us that structure can survive, that patterns, once established, can persist even when the matter they inhabit decays. This is the hidden message of black holes, not the inevitability of death, but the potential for continuity. Through curvature, through memory, through gravitational presence, even in collapse, something remains. And perhaps this is where we find our most intimate reflection. For human beings, too, are structures of carbon and chemistry, yes, but also of story, language, memory. We, too, carry information. And we, too, fear the silence that comes when it is lost. But the black hole does not fear the silence. It is the silence. And yet, it is not destruction. It is retention, a holding, a concentration so pure that it reshapes space itself. Could we live in such a way? Could we build not only upward, but inward? Could we become not only taller, richer, faster, but denser, wiser, quieter? This is not a call for retreat, but for depth. To see in the black hole not a threat, but a teacher. To model our thought, not on flame, but on gravity. To become less like fireworks and more like stars. There is a concept in physics called the last observer, a being, perhaps artificial, perhaps not, that might exist in the far future of the universe. After the stars have died, after the galaxies have drifted beyond sight, after black holes have evaporated into gentle nothingness, this observer would live slowly, carefully, drawing energy from the rarest fluctuations in the vacuum. It would think once every 1,000 years. It would store its thoughts in stable forms. It would be, in a sense, the last voice in the long symphony of existence. We do not know if such a being will exist, but the concept, again, changes us. It reminds us that thinking can continue even as light fades, that awareness can adapt, even in silence, that the story does not need an audience to be profound. And so we ask, what does it mean to be alive in such a universe? To be temporary, in the face of the eternal? To be warm in a cosmos growing cold? It means to matter not because we endure, but because we care, because we wonder, because we search the dark not for fear, but for understanding. This is the gift of the black hole age. Pulls us inward, not only physically, but intellectually, spiritually. It demands precision and patience and humility. And it reminds us that even the most silent object in the universe is a participant in its unfolding. Even the void has shape. Even the end has rhythm. And as we reach the close of this exploration, we are not diminished, we are expanded. We have traveled not with ships, but with thought. We have followed the thread of gravity to the center of the mystery. And we have found there, not despair but invitation, to wonder more, to speak less, to listen, because in the end, we are all falling inward toward meaning, toward each other, toward something we do not yet understand. And perhaps that falling is not failure. Perhaps it is the path. There comes a moment, at the end of every long journey, when the road becomes quiet and the horizon widens into something almost like stillness. It is not the stillness of nothing, but the calm of understanding. A recognition that though we may never hold the whole truth in our hands, we have touched its shadow, walked its curve, followed its pull. And somewhere in that experience between awe and curiosity, something has changed within us. Black holes have been our guides through this journey not only across space, but into the fabric of reality itself. They have led us from the collapse of stars to the origins of time, from singularities to multiverses, from pure mathematics to the oldest myths of human longing. We followed the trail of questions through science, through wonder, and through silence. And what they leave us with, in the end, is not a single answer but a greater depth of question. Because black holes, in their paradoxical nature, are both endings and beginnings. They represent boundaries where our laws of physics strain, where space turns in on itself, where time ceases to flow in any recognizable form. And yet, in all their finality, they also represent possibility. They show us that reality is more flexible, more mysterious, and more poetic than we ever imagined. We began with a simple but unsettling question. Did NASA detect a black hole moving toward Earth? A question rooted in fear, in curiosity, in the instinctive human response to mystery. But through exploration, we discovered that the truth is more subtle, more vast, that black holes are not threats lurking in the dark, but ancient engines of change, memory, and transformation. We learned how stars end their lives not with quiet fading, but with gravity collapsing them into darkness. We followed the physics of event horizons, of time dilation, of singularities that challenge the limits of mathematics. We considered the possibility that black holes could be portals or seeds of new universes, or the quiet monuments of civilizations long gone. We reflected on the holographic principle, the conservation of information, the paradox of memory in a universe that sometimes appears to forget. We listened for gravitational wave signals of distant cataclysms, long past but still arriving, still shaping the present. And through all of this, we found that black holes are more than objects in space. They are symbols of depth, of the unknown, of what it means to reach a limit and then to wonder what lies beyond it. And perhaps this is the truest legacy of a black hole, that it teaches us how to stand at the edge and not turn away, how to hold silence without fear, how to continue asking even when the answers fold into shadows. In that sense, black holes are deeply human. They mirror our dreams, our questions, our desire for continuity in a universe that appears to change without end. They mirror our grief for what is lost, and our hope that somehow, somewhere, it endures. That stories do not end with collapse but change form. The civilizations of Earthshave have only just begun to look outward. We have stepped outside our planet, sent machines to the edges of the solar system, and tuned our ears to the whisper of deep space. We are young, but already we are asking old questions in new ways. Could we ever send a probe into the heart of a black hole? Could we learn what lies within, not just through mathematics, but through touch? Through presence? The answer for now is no. But the question itself expands us, because every time we reach for what seems unreachable, we grow. And growth, in a universe that so often repeats, is a kind of miracle. Perhaps one day we will build instruments capable of detecting the signatures of civilizations near black holes, Dyson spheres around stellar corpses, encoded modulations in Hawking radiation, artificial gravitational anomalies. Perhaps one day we will speak across time, using the distortion of gravity to preserve messages for futures we cannot yet imagine. And if we do, those messages will not be technical alone. They will be stories, memories, questions. Because what endures in us is not just thought, it is meaning. And black holes remind us that meaning is not a thing we own, it is a thing we discover. Again and again, as we approach the edge, listen deeply and return with wonder. The stars will not always shine. The galaxies will not always cluster. The universe will not always be warm. But while there is thought, while there is motion, while there is the desire to understand, there is life. And where there is life, there is the possibility of beauty, of kindness, of curiosity, of awe. And these two are forces, not physical, but real, not measurable, but transformative. So we return once more to the black hole, not to explain it away, but to thank it for its silence, for its challenge, for the invitation it offers to grow our minds beyond comfort, beyond certainty. The black hole does not speak, but it listens. It pulls, but it does not destroy all. And what it holds may not be lost, but preserved in forms we have not yet learned to read. Perhaps one day we will. Perhaps one day we will sit at the edge of the last black hole, in the far twilight of the universe, and remember this time when we first looked up and wondered. And if that happens, if anything of us remains, it will not be our buildings or our wealth or our conquests. It will be our questions. They will be our legacy, because to ask is to believe that something can be known. To wonder is to remember that we belong, and to gaze into the darkness and keep looking is to love the universe, even when it hides its face. So let us keep watching. Let us keep asking. Let us keep listening to the gravitational rhythm of the stars, to the silence between galaxies, to the breath of the cosmos as it folds itself into form after form. And when the last light fades, may we still be searching, not for power, not for escape, but for meaning, because perhaps, in the end, that is what the black hole has always been: a gate, a mirror, a quiet promise that even the most profound darkness is still part of the story. And that story continues.